Hey everybody, it's Joel Irway with dailyfeexamprep.com, and in today's video we are going to be discussing law of cosines with regards to finding missing angles and sides of a given triangle. If you're following along with the general FE exam specification, we are going to be talking about subject matter mathematics and advanced engineering mathematics, and the particular topic is analytic geometry and trigonometry. Okay, so let's get started. Today's problem is find the remaining sides AD, DC, and DB in the following triangle, where AC is equal to 30, AB is equal to 20, and BC is equal to 25. Now, the law of cosines is the quickest and easiest way, in my opinion, to solve for this problem. You can divide this triangle up into two triangles and solve for a common unknown, which would probably be side BD. But that takes a lot of time, and to be honest, using the calculator to solve this is going to be much easier and save you a ton of time. So we can locate the law of cosines formula on, where did I have it? Right here. We can locate the law of cosines formula right here on page 19 of the NCEES supplied reference handbook, right here. And you can see that the general format is a squared equals b squared plus c squared minus 2bc cosine a. And that's what we're going to be using to solve for this problem. Okay, so let's get started. So let's go ahead and write down our formula that we're going to be using. A squared equals b squared plus c squared minus 2bc cosine a. Let's just put that in parentheses. All right, now you can pick any angle that you want, but I just so happen to pick angle A, and that's what we're going to stick to. So let's go ahead and fill in our givens, and once we do that, we'll be able to solve for the rest of the problem. So we have 25 squared equals 30 squared plus 20 squared minus 2 times 30 times 20 cosine angle A. All right, so let's go ahead and solve for all of our loose terms. So if we take all of our loose terms, we get minus 675 is equal to minus 1200 cosine A. And dividing 675 over 1200, we get 0.56 is equal to cosine A. And I'm sure you know all we do to get the angle is to take the inverse cosine, which will give us an angle of A is equal to 56 degrees. All right, so make note of that because we're going to use that to solve for the rest of our problem. So we know that our angle is 56 degrees. So now let's go ahead and solve for the remaining sides. So if we want to solve for AD, we know that the cosine of this angle, angle A, is going to give us the adjacent over hypotenuse. Okay, so if we take the cosine of 56 degrees, that will equal side AD all over side C, which we know AB is equal to 20, which is side C, so all over 20. So 20 cosine 56 degrees is equal to 11. So AD is equal to 11. All right. Now let's go ahead into the next one. Let's find DC now. DC is very simple. So DC, side DC, right here, is simply AC minus AD, which we know AC is 30 minus 11, which we just found out. So DC is equal to 19. And finally, let's find the last side. Side DB, which is right here, can be found using the tangent of angle 56. So if we take tangent of 56 degrees, now remember the tangent is going to be the opposite over adjacent. So that is equal to side DB all over AD, which we know is 11. That is going to be 11 tangent 56 equals DB, which equals 16. So our three sides are AD is equal to 11, DC is equal to 19, and DB is equal to 16. So I hope you enjoyed this video, and if you did enjoy it, or if you have any questions or comments, please leave a comment below and like the videos on my YouTube channel. And if you would, share any video that you find pertinent and share it with your engineering friends so we can help spread this word of the dailyfeexamprep.com. This has been Joel Irway, and I'll see you in the next video.